Let's go back to the statement so we know where we are. 12.1.3. And are you still with me? Okay, very good. My screen froze, so I thought maybe something would... All right, so here we have... So what we want to do is we want to map these numbers to that picture. So should I use OneNote? Maybe I should use OneNote. How about that? So let's go back here. And then we'll insert it. And then we can put everything in one place. But it's not responding. Let me pause my Dropbox. Maybe that's choking my bandwidth or something. All right, so let's insert. And it does not want to insert. There we go, finally. Screen clipping. Oh, sorry. Yeah. Yeah, you have to tell me when I'm doing stuff because I just sort of forget if I'm not doing it. Let's move this down. All right, I'll move it down, then I'll share. How about that? All right, so here we are, and let me go back to screen share. All right. All right, my screen is sharing, and I have my OneNote here. All right, so now we've got this, and is that writing big enough? Okay, whoops. Okay. All right, so let's go. I'm going to clip the picture, because the picture is very informative. Now, if my computer will actually just move, very stubborn today. Very, very stubborn. Here we go. Okay. And the figure's gone. Okay, let's see. How is that possible? Oh, there we go. Finally. All right, so we'll copy this, and then we'll move it here. Where's my OneNote? Let me close some other stuff. Maybe I'm choking it again. It's always good to close stuff if things aren't working. Close. All right. So I copied this, and I'm going to paste it into my OneNote down here. And it didn't paste, so I think I'm going to have to paste the screen clipping. There we are. So I'll paste the screen clipping. All right. Now I think we're rolling. All right. So first of all, we have Moses. The part A is what Moses sends. Okay. So he's going to send G to the n mod P. Right? Or mod G to the n P. All right, that should be clear. Right? That's what he sends. Right. All right, that's good. All right, now for part B, what you want is so Moses is sent. What's the number he sent? Some strange number. And that's what's given in the problem, right? Well, wait a minute. What it says in the problem is, well, all right. That's what he sends, right? Well, that's what you calculate he sent. But he has sent this. Moses has sent this. So I wrote this, so you stood me wrong. Okay. Oh, sorry. Okay. That's the number that he sent. Right? Okay. Now, that's this R, right? Because he sends Q and then he gets sent R back again. Okay? So that's your R. And the shared, there is no, you don't know what M is because you're Moses. Moses doesn't need to know M. That's yes. That's the whole point. Whoops, sorry. That's the point. And just use that same spreadsheet to do that calculation. Right. So I think once you've got that, I don't remember how many of these I assigned, but that's really the basic process for all of them. And the point that you made is you don't know M. It's very difficult to find M, and that's why it's secure. Okay. Now, I would like to make the point that although this section looks different from the next one, it's really the very same principle. Where you go, if you look in this, because you have the same diagram here. Instead of computing modular powers, you're computing these elliptic powers. Otherwise, it's exactly the same procedure. So I don't know if you've gotten into this section, but in the modular, you are raising g to the nth power. So that's g times g times g times g times g, etc. And the power you choose is your choice. And then your partner has their choice, and somehow you combine these two choices to get a combined choice, and you get a shared secret. Now here, instead of doing repeated powers, you do repeated sums. The group operation here is a plus and not a times. And a lot of these problems is just working out the mechanics of how to add to points. But then you get down here where you actually do the cryptography. And you'll see that the diagram is virtually the same. Now, the difference is that you don't send a number, you send a pair of numbers. And this pair of numbers is a point on your elliptic curve. So your shared key is actually a pair of numbers. All right. So if you haven't read that, you can read through, but just keep in mind that once you understand this elliptic curve group, then the mechanics of the cryptography is the same. It's no different. Okay. Well, I think, I'm thinking that I'm going to just have to have more sessions because, like this, because I can talk ahead of where you are, but it's not going to help. I don't think very much. I really have to address the issues that you're facing. So what I can say is I do suggest you email me with questions because the time that I have free is noontime your time, but that's probably not a good time for you when you're teaching. So I suggest that you email me, and when you're stuck, you can send me a screenshot, and then I can help you on from there. No, so I understand. So I did push back the due date for this assignment to the following weekend, but you should work on this in parallel with the next assignment, because we really have to finish to meet the standards of the course, we really have to finish through through cosets. Well, ideally we would get through this other coding one, but we have to finish equivalence classes cosets, and I'll have to decide whether we have time for 15 or for 16, one of those two. So I think that's what I'll have to say. It's just keep on working. If you get stuck on this, do equivalence classes. I hope that you've seen equivalence classes before. In fact, they're very similar to modular arithmetic, so I'm hoping that will be fairly straightforward, and then we'll just move on from there. I will probably end up pushing back the due date for equivalence classes, but I'll like I said, I think you should work on the two in parallel. All right. Now, since I'm not saying anything new,